All right, so today is our day 2, and now we're doing the reverse. So today we're doing how do I solve log equations. So before we did exponential equations, now we're doing log equations.
Right. And a log equation is an equation with a log expression that contains a variable. So to solve a log equation, you're going to change to exponential equation and solve for x.
Okay.
And so I have a little, looks like I have a little property here. If log base b of x is equal to log base b of y, then you can assume that x is equal to y. And that's going to come into play in some of our problems. If you recognize the bases are the same and they're set equal to each other, you can drop the logs and just set x equal to y.
That makes sense.
So now yesterday, like Miss Boyd said, we solved exponential equations. What we did is we changed the exponential equation to a log equation and solved for x. Today, we're doing the reverse. So we're solving log equations. So therefore, we're going to change log's equation to exponential and solve.
Okay.
Pretty darn easy.
She says now.
Yeah. All right. So let's go to the next page. Example number 1. Right away, I see a log equation.
Yes.
If you see a log equation and it says solve, you're going to change to exponential. So whenever you change to exponential, you start with the base.
Oh boy, I'm trying to write change and it's not working. There we go. Change to exponential. All right.
All right. And you're going to need probably all that space.
All right, I got you.
All right. So if we change to exponential, we start with the base, which is 6. And you raise it to the exponent, which is -1. Remember, log equals exponent.
Okay. So 6 to the -1.
Yep, equals 2x minus 1. And yesterday what I showed, I shouldn't say yesterday, a couple days ago, I showed the wraparound.
Oh, yeah,
where you start at the 6. So maybe, do you have room to do that? Not there, like up there where you take, see
Got
this?
it. Oh,
yeah.
Yep.
I don't know if you have room to
So
do that. So
this
6 to
goes
the
in
-1 is
that.
that.
Got
That's
it.
how it works. Okay, well, 6 to the -1, let's change that right away. I don't like negative exponents.
No.
That's the same thing as 1 over
1/6.
6 because it's the reciprocal.
Okay.
That's equal to 2x minus 1. Well, I don't like dealing with fractions,
I don't either.
so we can multiply the whole darn thing by 6.
6.
So I'd put a big parenthesis around both sides and put a 6 on the outside.
All right.
And when we do that, on the left side, you get 1, and on the right side, you get, right,
So we get
12x minus 6.
minus 6. Okay.
Well, now this is just an easy algebraic equation.
Add 6.
Yep.
So we get 7 equals 12x.
Mm-hmm.
Divide by 12.
Right.
And we get x equals 7 over 12.
And we're done. That's pretty
Perfect.
straightforward. Let's go down to example 2, because now we're throwing a couple things in.
There's a lot going on here.
So number 1, if you go back up to example 1, there was a single log. When you have a single log, then right away you change it to exponential and solve.
Okay.
Here we have more than one log. So before you can technically start this problem, you have to change it to a single log.
Okay.
And when you so number 1, the bases are the same. They both have a base of 4. And because we're subtracting, we can write it as a single log by dividing. So we're going to write right now log base 4, and in parentheses, you're going to write 100 over x plus 1. And you're going to set that equal to 1. We've just made a double log into a single log.
So now we can do our...
Yep.
So we
Correct.
have 4 to the 1
Equals
this.
100 over x plus 1. Well, now again we have a fraction. So let's put a parenthesis around the whole thing, because you can get rid of a fraction at any time as long as you x plus 1. You multiply what's in the denominator. So as long as you multiply it on both sides, you're fine.
Okay.
So if you multiply the left side, you're going to get 4x plus 4.
Just 4.
Yep, 4 to the
So
1
we
is
got
4.
4x, and then 4 times 1 is plus 4.
Yep, is equal to 100.
And yep, those then cancel on this side, and we're just
Right.
left with 100.
Right.
All right, now we can solve it. Oh, that's easy enough.
Subtract 4.
4x equals 96.
And then you divide both sides by 4. X is equal to 24.
Nice.
And we're done.
All right.
Not so
So
bad.
really it's more just being able to decide what do you need to do from
Right.
Okay.
Exactly. Now I think we should do example 3 because again it's something different. I see 1 log.
It's
However,
a power.
I see a power. So the minute you see a power, because if we go back really fast to example 1, there was no powers going on. So we changed it right away to exponential. Here we have a power. So you always want to try to use a property first. So let's use the power property, which is bringing the 4 in front.
Got it. Baseballing it. So we have 4.
Yep.
Log base 5x equals 8.
Right. And you know what?
What here?
Actually, you know what?
What?
I am wrong. Can you erase what we just did?
Sure.
I apologize for the
We all
mistake.
make mistakes.
Because actually that's going to make it more
I was
difficult.
gonna say.
I
think that's gonna be really
apologize.
hard, but that's okay.
It's been a long day.
Let's make it easier.
All you have to do, I apologize. Let me rephrase what I just said. Whenever you have more than 1 log, you have to change it to a single log.
Right.
If
we
you
have
have-
a single log.
If you have
also.
only a single log, right away change to exponential.
Okay.
All right? So even teachers make mistakes.
Yeah, that's fine.
So 5 to the 8th
To the 8th.
is equal to x
To
to
the
the 4th. There we go.
All right.
But now, if we would have an x squared,
Mhm.
everyone would say, oh, you take a square root. We have an x to the 4th, so we take the 4th root.
So that would just cancel.
Mhm.
So we're gonna do the same thing here. So we're gonna
Right.
take the
And there's a 4 on the
4th
outside
root,
on
yes.
each side.
4th root.
So the 4s will cancel over there, and you get x. And over
So
here,
we just plug this in our calculator.
yep, and when you do that, so you're going to plug in 5 to the 8th and then take the 4th root of 5 to the 8th. And we can go over that if you need help, but that's pretty easy on our calculator. You get a nice answer, actually,
Oh.
and it's 25.
Sweet.
And if you're unsure, the graphing calculator or the regular calculator
Mhm.
has a math button.
Okay.
And then you can press number 5 and you can choose that you want the 4th root.
Got it.
Because I don't think it's an option like on the main screen of a calculator.
Okay.
All right. Oh, you know what? One other thing then.
Mhm.
When you put the root on the calculator, it's so tricky. Make sure you put the number 4 on the A on the
Oh.
word ANC.
So in calculator,
Yeah,
it will have a
calc.
Thank you.
ANS. It will say ANS for, yeah. That's what it says on the calculator. You want to put the number 4 on the A.
So we'll plug in a 4 here.
Yep,
Okay.
right there.
Got it.
We can go over
Yeah,
this
we'll
if,
go
if
over
you
it
don't know how to
next.
use your calculator. Okay, next one.
Mhm.
I think we should actually do it,
Sure.
okay? So there's 2 logs.
Yep.
We have
So
to
we
make
gotta
them to
simplify
a
first.
single log. And
So
because
we
we're
add-
adding, we're gonna multiply.
So log base 12
Mm-hmm,
x times x plus 1
right,
equals 1.
exactly. Well, let's multiply that. So we get log base 12, and maybe in parentheses, let's write everything. X squared plus x equals 1. Now we have a single log, so now we can change it to exponential. Yep,
So we have 12 to the 1, which is just 12.
yep, equals.
Equals x squared plus x.
So notice what we have here. We don't just have a simple linear
No,
equation.
We have it squared. It's
You have a quadratic, so guess what we're gonna have to do?
Set it equal to 0.
Yep,
So since this really is 12, I'm just going to subtract 12 from both
Yep.
sides. So we get 0 equals x squared plus x minus 12.
and we can factor that.
Yes.
And I'll
it's
scroll
nice.
down
It's
for
a
you.
3
It's-
and 4.
Yeah, so let's do
Perfect.
that.
So if we factor this, we have a positive 4
Yep,
and a negative 3.
and we set, and that's still equal to 0 over on the left side there.
Just a quick reminder, because 4 times negative 3 gives us negative 12, but 4 minus 3 gives us the 1 we need. Okay.
And we did say factoring would never go away.
Right.
Yes.
But they think sometimes we lie.
Yeah. Now
So we're
set
gonna
each
set them each
factor
equal to
equal to
0.
0.
And we get negative 4
Mm-hmm.
and positive 3.
Mm-hmm. Now, okay, here's where the trickiness comes. On these problems, you have to check your answers
Okay.
because there is a reason.
Yes.
If you plug in the log of a negative number on your calculator, you get an error.
Like right here.
Yeah. Now, let me make sure you understand. Just because I have a negative answer doesn't mean it's always not going to be an answer we can use.
Okay.
But if you look, if you go back up to the beginning, if you have log base 12 of x, if you plug in a negative 4 there, there's an error right there.
Mm-hmm.
So right away, you cannot use that. You don't have to check the 3 because it's not negative. But if on top, it would have been like x, instead of x right there, x plus 5
Oh, yeah. So then negative 4 plus 5 would
is a
give
positive.
you a
And
1.
if this would have been x plus 6, you know,
Mhm.
you got to check both sides. You can
Okay.
never take the log of a negative number. So
So
cross
always
off
check.
negative 4. It's not an answer. The only answer here is 3.
All right.
That's it. Kind of tricky. We might have to talk about that
Yeah.
more. Okay, so it looks like we have, let's see what else. I'm wondering if we should, because we really haven't saved any for class yet.
Right.
I just want to take a peek at, no, these are pretty straightforward what they
Yeah.
can do, okay? Should
Let's
we
save those
save
for
5
class.
and 6 for
Sure.
class? All right. So video question 1, solve. You have a log plus another log.
Right. You have a plus.
So
That
you have
means
to
you're
make
gonna
them
multiply.
into a single log by multiplying and change to exponential.
Mhm.
And over on the number 2, you
Yes,
have a
yes.
log and it's a single log. So right away you change it to exponential and then you
Mhm.
plug that into your calculator.
Okay.
See you
tomorrow.
tomorrow.